very interesting and very, it will be very, useful for all those aspirants who are appearing for the NET or JRF examination or the SRF examination. So without getting further delay, so let's start the topic, today's topic. So let me share the screen.
Ma'am, please go in full screen mode, ma'am.
Yes, yes. Is it visible, Suman?
Yes, ma'am, visible.
Okay. So today's topic is soil air aeration and its management. So today I will cover the topics composition of soil air, aerobic and anaerobic respiration and decomposition, and the different method of gaseous exchange like the mass flow, diffusion, and then we will also discuss determination of the quality of soil air, and at last we will discuss soil compaction and consolidation, and various type of questions I will also discuss. Those are some important questions like in various examinations they are asked, and which covers the conceptual part. What happens that if you will see the pattern of examination for the JRF and SRF. So before the 2015 or 2017 up to 2017, they were the questions asked like the factual questions that can be directly if you read the DK Das or those basic books like the TD Biswas and Mukherjee. So most of the questions you will be able to solve, but in from the last 2 years most of the questions are asked like the assertion and reason. So for the qualifying examination you can go through the DK Das and TD Biswas, that will be enough, but for the getting good rank you have to clear all the basic concepts for the JRF and SRF examination. But in NET examinations factual questions are asked, so information based. So I will try to cover to clear your concepts, and so you can ask the questions in between that if you have any queries. So soil air, why it is important? As air is important for human beings also for the respiration, to take the oxygen and to produce the carbon dioxide. And we study in as the definition of the soil that soil is a living system. Why it is called? Because the soil is the habitat of the living organisms like the microbes, like the roots, plants, and several several animals. So the soil air is also important for those living beings. Soil air differs from the atmospheric air in several respects. In the right hand side you will see that soil is a heterogeneous system. So it has the solid phase, liquid phase, and gaseous phase. So in the solid phase, we all know that 45% of compositions are mineral matters and 5% are organic matters. And 25 to 30% are water and 25 to 30% are air. You see here these arrows are shown in between the water and the air. This is because it is the dynamic. As the water and airs are filled in the pores of the soil. So if the water will be filled in the water in the pores, then the air composition will be less. So it shows a dynamic property. So that is here it is written that the composition of soil air is quite dynamic and varies greatly from place to place within a given soil, just because of the depending on the soil moisture content. See in the pores there where is the moisture content are higher, then there will be low air present. So second, soil air generally has a higher moisture content than the atmosphere, and it may reach up to the relative humidity of 100% when the soil moisture is optimum. See in atmosphere 100% of relative humidity is very rare, or we can say that in the rainy season or when there is the
क्या बोल रहे थे कि बहुत हो गया बहुत हो गया।
मैं कहाँ बोला हूँ ये नया
Participants, please mute your audio. Aman Verma,
यस मैम
kindly mute yourself
ओके ओके
if you have no any queries. So in the rainy season or when the moisture is optimum in atmosphere, then only the relative humidities are up to 99.9% or 100%. But in soil, it used to happen that there is the relative humidity 100%. Whenever is the soil moisture is optimum, or we can say that the saturated condition. If we give the water in saturated conditions, there is the then there is runoff of the water. Then it's reached to the relative humidity of 100%. But in soil, but in atmosphere, it is rarely happens, or it is very low. Third, carbon dioxide in soil air is often several times higher than the 0.03% in air, commonly found in atmosphere. See the you will see in next slide that the composition of air, like the nitrogen, oxygen, and carbon dioxide, and the other gases are in the trace amount. So we will not discuss about them. Nitrogen is almost constant, and oxygen, even in the gaseous phase, oxygen and carbon dioxide are dynamic. So you will see that carbon dioxide content is several times or the significantly higher in soil air, or up to 10 times, or maybe it may increase to several times, depending on the microbial activity or the root respiration. So what happens? Carbon dioxide is higher just because biological activity, temperature, organic matter, moisture condition, etc. We will discuss it further in details. In this table, you can see that there are the different type of the different texture of the soils, and with the different textures, the composition of carbon dioxide and oxygen also differ. You will see in manured soil air, maximum carbon dioxide is there. This is because in manured soil, we are giving to the soil organic matter. So higher the organic matter, there will be higher the rate of microbial activity. So as the microbial activity increases, their population increases, their metabolic rate will be higher, and they will produce more and more carbon dioxide. So carbon dioxide is maximum in manured soil. Now we'll discuss the factors affecting the soil air composition. So first one is the most important, soil respiration and the biological activity. Soil respiration may be due to the roots or any higher plants or the any plant's root, and biological activity. Biological activity, it is related to the microbial activity. If their population will increase on the addition of the carbon matter or any carbon sources, then they will respire more and more. So carbon dioxide will increase, and oxygen concentration in soil will decrease. Next is the soil organic matter. So soil organic matter is itself the same thing, that as the soil organic matter increases, so there will be the higher activity of microbes. It is interrelated. Then is the effect of cropping and tillage. Effect of cropping, that means that if you will see in the fallow land, and another one is cultivation, there is some cultivation, you will see that carbon dioxide content will be higher in cultivated land. This is because there is the roots, and having the roots, so the microbial activities will be there. It will be host for several microorganisms. So there will be carbon dioxide production will be high rather than the fallow land. Tillage. So tillage practices, it loosens the soil. So what happens, that it loses the soil means the soil porosity will increase, and also it affect up to the depth, to what depth we are doing tillage. And the another one is the soil moisture and soil depth. Soil moisture, soil moisture as the increases, so it will decrease the soil air composition, because both are present in the voids or the pores of the soil. So only If soil moisture will be saturated, then there will be no air present. Okay. And soil depth means that if we will go to the subsoil or to the depth of the soil, so in depth of the soil, there is compaction layer will increase. If compaction layer is increasing, then the soil aeration will be poor. And oxygen, you will see oxygen will be higher in the surface layer than the subsurface layer. This is because the microbial activities are also higher in the surface layers due to the optimum conditions, and in the subsurface due to the lower microbial activity and compaction layer, so soil erosion will be poor. And the most important point is the macropores. Macropores, macropores like the soil texture, bulk density, and aggregate stability all affects the macropores. So in the sandy texture, we see that there are the large number of macropores. Then the clay soils. So having higher the macropores, so there will be the higher the soil aeration. And depending on the texture, there will be the microbial activity also affected. So, and the aggregate stability, you see, if there is the poor aggregate stability, so if there is the poor aggregate stability, so there will be the poor aeration. Hemant Ravindra Khadse. Please mute yourself if you have no any queries.
Continue, ma'am. I meet himself. I meet yourself. मैंने उसको mute कर दिया है, मैम आप शुरू करो.
Okay, up to now, anyone have any doubt or any queries? You can ask.
No, ma'am.
Okay, the last point is seasonal effect. Okay, seasonal effects means if there is the rainy or the for the microbes growth, there should be the temperature, optimum moisture conditions, and the nature of the air. So these all affects the growth of the microbes. So what happens in the rainy season or in the rain, it increases the moisture content in soil. So optimum moisture conditions will provide the optimum condition for the growth of the microbes. So in the rainy seasons, what happens? The process of the nitrifications, decompositions, these all will be higher. So if it will be higher, then in soil carbon dioxide concentration will be higher. Okay, one question is asked. Okay, if you are all have no any doubts, then I'm asking you a question. That a question is asked in several books or somewhere, that in which season pH is higher, in winter or summer? If anyone knows the answer, kindly unmute yourself and you can give your answer. I'm repeating the question. In which season pH is higher, in winter or summer?
Winter,
Winter, ma'am.
Why?
because ma'am, winter comes after rainy season, and in rainy season, soil surface erosion occurs due to water, and aluminium ions accumulate into the subsoil surface, and this increases.
I think you have guessed a right answer somehow, but you don't know the reason.
Okay, ma'am.
So misconception is very risky than having no concept. If you don't know the concept, that's okay. But if you have misconceptions and you make some misconcepts about the anything, that is the more dangerous. That will do negatives in your examinations. You will not leave that questions. No, I know. I will attempt these questions. And what you do? You do the negatives. Anyone else? Okay. Answer was the right. In winter, pH is higher than the summer. This is not because of it comes after the rainy season. Actually, what happens, you will see in winter and summer, in summer temperature will be high, or in the winter temperature will be the limiting factor. But in summer, moisture is the limiting factor. So what happens? that wait. What happens that in winter having the moisture condition optimum, so pH will be actually low in winter. Okay. So because no, pH will be higher in winter. This is because in summer the decomposition of organic matters are higher. Okay, so in winter due to low temperature and due to the optimum temperature will be no there, so the decomposition of organic matters are less. What happens that when the organic matter decomposition occurs, so it produces weak acids. So as the weak acids are produced, okay, and like the carbonic acid or citric acid or like that, so weak acids will decrease the pH. So that is why winter having the higher pH than the summer. Okay.
Ma'am, how weak acid is produced in winter?
No. Actually, it depends on the decomposition of organic matter. For the organic matter decomposition, we need the optimum temperature and the optimum moisture. Okay. For the microbial, because it is done by the microbes. It is not the chemical decomposition. It is completely biological process. So for the biological process, we need the optimum temperature and optimum moisture. So in winter, there is very low temperature, there is classification of the temperature like the mesothermic, psychothermic, as we read, na? Types of the microbes like the psychrophiles, mesophiles, we study, na? So
Yes,
most of the microbes are the mesophilic. Okay, they lives between the 20 to 30 degrees Celsius optimum, there is optimum temperature. But in winter, it is very low, less than the 10 degrees Celsius. So there will be low rate of decomposition of organic matter. Okay.
Yes, ma'am.
So we read the soil respiration. So soil respirations are also in soil. There are two types of the respiration: aerobic respiration and anaerobic respiration. So you see, both are the cellular respiration. In aerobic respiration, it takes place in the presence of oxygen gas to produce energy from the food. This type of respiration is common in most of the plants and animals. And in this process, water and carbon dioxide are produced as the end products. You see in this equation, energy is producing. Okay, and byproducts are carbon dioxide and water. But in anaerobic respirations, where if there is the low oxygen present in the environment, like in waterlogged soil, okay, or anoxic condition, where is the low amount of oxygen, not the completely absent, that is called as the anoxic. So what happens there? That the energy will be not, the glucose will be not completely decomposed. So ethanol will be produced or the lactic acid will be produced. And the main difference between, as a point of the soil scientist, the questions are mainly asked, like the electron acceptor in the aerobic respiration is oxygen, but in anaerobic respiration, it may be sulfate, nitrate, manganese hydroxide, carbon dioxide, or anything other than the oxygen. This is because, when the decomposition of organic matter occurs, so what happens? Organic matter or the glucose source or any carbon source, what happens? The electron is produced. So in the final, in the last steps, electron is accepted. So in aerobic respiration, oxygen is there. So oxygen is there to accept the electron and get reduced. But in anaerobic respiration, oxygen is absent. So microbes uses another compound, like you will see in sulfate there is also oxygen. In nitrate there is also oxygen. Manganese oxide, carbon dioxide, everything, every compound has the oxygen, but it is not as the free oxygen. So these are as the electron acceptor, and they get reduced. For example, you will see that sulfate is reduced and it forms finally H2S, hydrogen sulfide gas. You will see, maybe you have read that in waterlogged soil, hydrogen sulfides are produced. This is because of the reduction of sulfate. Okay. And you have read in rice also Akiochi disease is there. That is also because of the toxicity of hydrogen sulfide. These are all toxic gases. And if the nitrate will be reduced, it will produce nitrogen. And we read that as the denitrifications. So till here, anyone have any doubt? We will discuss it in later part of the redox potential. Okay. So no queries? You guys can ask. Okay. I think I'm clearing all your doubts, right? So that's why you don't have any queries.
Yes, ma'am.
Okay, these are the two types of the anaerobic respiration. You have read that in the left hand, due to the lack of oxygen, ethanol is produced. Okay, pyruvate is 3 carbon compounds, right? So when due to the lack of oxygen is there, so ethanol is 2 carbon compound and 1 carbon is produced as the carbon dioxide. Okay, note all the compounds are producing carbon dioxide. So 2 carbons are forming ethanol, and in the right hand side, lactic acids are produced, okay, which is in humans and muscle cells are there. So we are not focusing on lactic acid formation. We have to focus on the which happens in soil. So mostly ethanol is produced in anaerobic condition, okay, due to the microbes or in yeast. So now we will discuss the aerobic decomposition and anaerobic decomposition. See, before starting decomposition, we will discuss the difference between the respiration and the decomposition. You know, respiration is the cellular respiration, that is, it happens inside the cell of microbes or the roots. But decomposition occurs outside of the microbes, outside the cell of the microbes. Okay, and you will see in respiration, you know, glucose is breaking down. Okay, glucose is breaking down and it is producing energy or ATP. But in decomposition, here also the glucose is breaking down in presence of oxygen. But here energy is not produced, but heat is getting produced. That is why where is the decomposition occurs, so there is the high temperature. It may be somewhere asked in questions as in the question form. So in anaerobic, you will see in aerobic decomposition, heat is produced, and in anaerobic decomposition, again you will see ethanol is produced and CO2 is carbon dioxide is producing. So this is not the balanced equation, right? Okay, it is balanced. So in presence of the different types of the microbes like the methanogens, these carbon dioxides are getting produced as the methane gas. You will see that for the biogas production, there are several types of the gases are produced, like the methane gas, ammonia gas. Those are all in the reduced form. If there will be the sulfate, then it will produce H2S. Okay, so these are the basic difference. Now we will discuss the gaseous exchange. So why soil air is important? We know what are the factors affecting soil air and what is the decomposition, what are the types of the respirations. Okay, those are all the affecting the soil air composition. Now soil air, we will discuss about the gaseous exchange between the atmosphere and soil, and also soil to the plant. Okay, so there are basically two methods. One is the mass flow and another one is the diffusion. So the mass flow occurs due to the total pressure gradient of gas. This is the important sentence, that total pressure gradient. Question is asked and option will be there, that it depends on the total pressure gradient or the partial pressure gradient, like this. So it It occurs due to the total pressure gradient because it is happening in the mass. Okay, and it is happening due to the pressure difference, pressure gradient from the higher pressure to lower pressure. So the pressure gradient causes movement of entire mass of air from a zone of high pressure to that of the low pressure. Such a flow of air occurs within the soil or from the atmospheric air to soil air or vice versa. Okay, so if in soil, as we study that carbon dioxide is higher concentration, so it will always diffuse, it will always move out from the soil to the atmosphere. And if the oxygen concentrations are higher in atmosphere than the soil, okay, if this in soil microbial activities are higher, carbon dioxide is more and more, so the oxygen will be less. So if oxygen is less in soil air, then from the atmosphere oxygen will comes to the soil and through the mass flow. So when the soil temperature is higher, it is affected by the soil temperature. So if the soil temperature is higher, then the atmospheric temperature during the midday and the soil gases will expand. Temperature causes the things to expand. So whenever it is expanding, so it is getting low density. So what happens? It moves out or it always rises. So move out of the porous spaces into the atmosphere. So when the soil is cooler than the atmosphere during night, then the atmospheric gases enter the soil. And when the atmospheric pressure is high, the atmospheric gases will enter into the soil. And it is affected by the barometric pressure. Okay, barometric pressure means the atmospheric pressure, or mass flow is depending on the pressure, total pressure. So it affected by the barometric pressure. From the higher pressure to, it will move towards the lower pressure. And the temperature, as the temperature will increase, the mass flow will also increase. Okay, and the wind gust means if the at the surface of the soil, if the higher the wind speed. Okay, so just think that from the soil surface our gas is moving out. Okay, it is trying to come out or rise, but at the surface there is the high wind speed. High wind speed means it's forcing down those gases that you don't come out. We are forcing you. So wind gust will decrease at the surface of soil to gaseous extent, okay, of the mass flow. Next is the diffusion. The gaseous interchange between takes place by two types of the diffusion at first. Okay, diffusion of the gas types in soil air spaces, as I told you. Okay, from the soil air spaces to the atmosphere. And another one is diffusion of gas in solution through the liquid phase to plant roots. Plant takes questions are generally also asked that from the which type of the method plants use mostly gases through the mass flow or through the diffusion. So you will see that generally diffusion is the main process through which plants take gases. So diffusion, through the diffusion, it is the process by which each gas tends to move in the space occupied by another as determined by the partial pressure of the gas. In mass flow, what was there? There was the total pressure of the gas. Total pressure of the gas means there is the oxygen, carbon dioxide, completely all the gases. But in diffusion, partial pressure of the gas means individual pressure of the gas. Okay, if what I told you that oxygen, oxygen concentration in soil air is low and in atmosphere it is high, then from the atmosphere to it will move downward or into the soil. But carbon dioxide concentration is high in soil air, then it will move out. So it is depending on the partial pressure of the gas, individual pressure of the gas. The partial pressure of oxygen is higher. See here it is the example given that the partial pressure of oxygen is higher in atmosphere than in soil porous spaces. Then partial pressure of CO2 is and CO2 is higher in the soil porous space than the atmosphere. So what happens? So oxygen will comes from the atmosphere to soil and CO2 will moves from the soil. However, the total pressure both in the soil and the atmosphere may be same. Thus, oxygen will move into the soil and the CO2 will move out of the soil. So for the diffusion, there is the mathematical terms. From here also question was asked. There is a two type of diffusion I discussed: diffusion of gas type in soil air spaces, and the another the diffusion of the gas in the solution through the liquid phase to plant roots. So Fick's law, that is the Q is equal to minus D into concentration gradient dC by dx. So it is for second point, diffusion of gas in solution through the liquid phase. Actually, Fick's law applies on that second point, where Q is the flux across a plane, means the concentration of or the diffusion of the gases per unit time through the plane. And dC by dx is the concentration gradient. As the concentration gradient, it is minus sign is here. You will see that from the higher concentration to lower concentration it moves. That is why here it is the negative sign. Okay, and D is the diffusion coefficient. Questions are asked like Fick's law is applied where? It is on the diffusion process or the soil moisture content or like that. And from the diffusion coefficient, questions are generally asked that what is its value, and it depends on which factors like that. So you will see that diffusion coefficients depends on the moisture content and structure of soils. You will see as the moisture content will increase, then the diffusion coefficient will decrease. So the gaseous exchange will be low. And the structure of soil, you will see in the next slide, I have presented a pictorial presentation of it. So you will see there, we will discuss it later. And it is affected by the continuity of air-filled pores and the amount of air-filled porosity. You will see here. What is the air-filled porosity? It is the volume occupied by air per unit volume of the soil. Okay. So if in the total volume of the soil, what percentage of the voids are occupied by the air is called the air-filled porosity. You will see here in this soil texture, granular or single grains, there is the rapid gaseous exchange or the water exchange, actually both, because both happens through the soil pores. And in the prismatic, and there is the moderate, and in the massive or the plateau structure, there is a very bad, very poor soil erosion occurs there, because there is no soil pore spaces in the plateau structure or in the massive structure. But in the granular or the single grains, there is the lots of spaces, lots of the macropores are there. So the gaseous exchange occurs very rapidly. So, and air-filled porosities are, it depends on the air-filled porosity, but the continuity of air-filled pores are also important. What does it mean? You will see in sand and clay, for example. In sand, what happens? There is also air-filled pores, and in clays there is also air-filled pores. But you will see that in the clay, what happens? It is compact layer, or when the soil particles are closely packed. Okay, but in sand there is the lag between because there is the macropores. So the air-filled pores are directly linked in sands. But in clay, there is the micropores, and the clay particles are also there, which are attached to each other. So there will be the less continuity of the air-filled pores. So the exchange is higher in sand than the clay soil, and it is 10,000 greater in soil air than that in the soil water. And value in soil is usually between the 0.6 to 0.8. I think in NET 2021 last year, this question was asked, this data. Okay, in right hand side, you will see that air-filled porosity, as it is increasing greater than 10, you will see there is the good growth. Okay, and below which it is bad, or fresh wet is less, means the plant growth is less. So up to here, any doubt?
मैम ये एयरफील्ड पोरोसिटी वाला कॉन्सेप्ट एक बार फिर से समझा दो प्लीज.
Okay, wait. See, in voids, what happens? In voids, there is the soil, soil water, and soil air. So we are talking about the there is porosity. Higher porosity is in clay or the sand.
Clay.
Porosity is higher in clay. So porosity is high. but at what extent it is filled with the air or it is filled with the water. Okay, at what extent it is filled with the air is called the air filled porosity. So of the total volume of the soil, we see that at what volume is filled with the air is called the air filled porosity. Okay.
ओके मैम, मैम एक्चुअली मैं उसकी बात कर रही थी, वो जो आपने बताया ना प्लेटी स्ट्रक्चर में, क्ले स्ट्रक्चर में कम होगी एयर फिल्ड पोरोसिटी और
Okay, okay, okay. हाँ, तो you see ना, see the structure. There are the देखो in single grain or the granular, there are the gaps between the particles, right? So gaps between the particles, there are the large amount of the macropores.
Yes, ma'am.
This is not about the porosity. This is about the macropores or micropores. Okay. So in granular or the single grain, there are the macropores. Okay. So here the rapid exchange will be there. But in massive and platy, you can see there is no gaps or no less porous, and you will see there is no any voids. So obviously there will be less gaseous exchange.
Thank you, ma'am.
Anyone have another doubt or?
Ma'am, I have a doubt from soil temperature. Can I ask?
Okay. Soil temperature I will discuss in second half. Don't worry.
Okay, ma'am. Then I will ask.
Okay.
Right.
So up to here, anyone have any doubt? You can ask. So no doubt. I think I'm teaching good. So now the next point, determination of quality of soil air. Okay. So how we will say that the quality of soil air is good? For us, oxygen is most important. So if in the atmosphere carbon dioxide is, what happens if the carbon dioxide concentration is higher? Nowadays the most concerned part of the us human beings for the even existence, climate change, that the carbon dioxide is increasing, production of carbon dioxide is increasing day by day. So the global warming effect, greenhouse gases and all, so in the same way, for the soil air, there is it also important for the quality. So there should be a balance between the anything, okay, in nature. So there should be optimum oxygen and carbon dioxide. Okay. So how we determine that the quality of soil air is good? Okay. So we mostly study about the oxygen, because oxygen and the carbon dioxide is dynamic in soil. So first method is measurement of oxygen in soil air. So what we do that the oxygen content is nearly 20% in upper layer of friable, well-drained soils. Okay. In surface layer, up to 20% oxygen is there, and it can decreases to 5% or even less in subsoils. I told you, in the subsoil there is a compaction or there is the low microbial activity. So there will be low oxygen. So, but a significant amount of oxygen is dissolved in soil moisture. But what happens? Maybe soil air is low in subsoils, but if there is optimum moisture, groundwater, or we study, so if there is the optimum subsoil, in optimum moisture in subsoils, so oxygen is dissolved in optimum amount. It means it is useful, whatever amount it is needed for the plants or for the higher roots, or they can get oxygen from those moisture. So that is why on the first method we do not give much attention, or it is not significant. So the most important is the determination of oxygen diffusion rate. See, oxygen diffusion rate is the rate at which oxygen diffuses in soil. Okay, so oxygen may be there, but at what rate it is diffusing? Okay, maybe and its unit is microgram per meter square per second. The question is asked from the unit and the value also. Okay, so you will see the critical oxygen diffusion rate value is 20 into 10 to the power minus 8 gram. Okay, sorry, it's gram per centimeter square per minute. Okay, it is mistake. So value is important, 20 into 10 to the power minus 8 gram per centimeter square per minute. Why this is called? That below it, what happens? There is the there is the low amount of that, whatever the oxygen is present below this, so that will not be optimum for the plant growth. Okay, so the critical value is this, and above it, all the plants will be able to, all the plants will have the optimum growth. So the oxygen diffusion rate is important, but easier than the oxygen diffusion rate is the determination of redox potential. You will see here. In redox potential, you will see that redox potential occurs. Redox potential says that the in the millivolt, or we can easily by the electrode method, or we can easily determine the potential, and the redox potential condition can tell us the conditions of the oxygen. You will see here the oxygen to water. This reduction process occurs at the redox potential of 380 to 320. So if we know the reduction potential of the soil, we can say that our soil is the quality of soil. If it is less than the 320 to 380, then there will be less oxygen, we can say. Okay, there will be the other sources of oxygen. So threshold value by the several authors, this data is important. 350 millivolt for the start of threshold values for the threshold value is 350 millivolt for the start of the reduction of nitrate into nitrogen, and denitrification may occur below it. So 350 millivolt is threshold value. This is because below it what happens, the nitrate can reduce and denitrification there will be. So our soil needs, our plants need nitrate form of nitrogen. So if the up to this where the plants is getting nitrate form of nitrogen, up to that it is okay, but below the reduction potential, where the for the nitrate to nitrogen reduction, we need the redox potential of sorry, we need the redox potential of 280 to 220. Okay, so if redox potential reach to this value, then our nitrate will reduce into nitrogen and our soil will lose the nitrogen. Okay, so there should be a redox potential greater than this, and that is the critical value of the 350, up to which there is the oxygen present. Okay, and here you will see from this table is very important. You will read this in the waterlogged soil, and from here the too many questions are asked, like in CSIR 2020, question was asked in the order of this. There was nitrate, iron, sulfate, like this, and the question was asked like the if the oxygen in the submergence condition, microbes will use oxygen source from which to which, means it means firstly पहले कौन सा form of oxygen they will use. Okay, so you will see that it is order of the in the order of the decreasing redox potential. So at first they will use nitrate, then they will use manganese, then they will use iron, then sulfate, then carbon dioxide. Okay, and in last year in 2021 in NET event, the value was asked, I think for the sulfate or for the carbon dioxide, the values was asked, and this range was given. So even the data are important. At least remember this sequence, make any trick or anything, or even the data is also important. Ratta maar in simple words. Okay, any questions till here?
Ma'am, can you provide recorded classes? Previous
What?
recorded classes.
We concentrated on the classes. After that, we will discuss after all these things. Don't take all these types of things in the.
No. If you have queries related to this, then ask only. I will give you a chance to ask extra things also. Don't worry. Collect your doubts.
Okay, ma'am. Okay, ma'am.
Okay,
Excuse me,
anyone
ma'am.
have doubt? From the
Excuse me,
submergence
ma'am.
soils, it is very, from the submergence point, for the submergence soil, point of view of the submergence soil, this table is very important.
Excuse me, ma'am.
Yes.
Ma'am, oxygen diffusion rate, it means diffusion of oxygen from soil water to soil water, from soil water. The diffusion of oxygen takes place in the soil.
No, from the soil water it can't be, because in soil water it is in dissolved form, not as the free. So it will be in freely form, then only it will be diffusion, na? So it is in soil air diffusion rate we discuss. We do not discuss about the oxygen present in the soil moisture. For the soil moisture or soil water, we that we also study, and in the form of the BOD and the COD. Remember, biological oxygen demand and the
Chemical oxygen
oxygen
demand.
demand. In that form we study, but we are studying about the soil air. So in the aeration form, we study only about the free form of the oxygen.
Okay, ma'am. It means ODR is for free oxygen.
Yes. Diffusion occurs only for the gases.
Okay.
Any doubts? Anyone have?
Manganese is a gas, ma'am.
What?
Manganese is also gas, ma'am.
No, manganese oxide is a gas, not element. See, in soil, elements are present in as the ionic form, or if it is in the gaseous form, then it is in gaseous form, but as the manganese oxide, not the element is in gaseous state. Here, it is the manganese 4+. It means it is manganese oxide, but it is written as but in manganese oxide, manganese in the +4 form, na? So that is why it is written. But manganese is not directly gas as the elements. Manganese oxide is gas.
Okay.
Ma'am, please explain redox potential.
Redox potential. Okay. It is the potential to which the oxidation occurs. Okay. In soil, what happens? Here you will see, the higher the negative value, the it will tends to oxidize. Okay. Redox potential means reduction plus oxidation. You have read in class 12 in chemistry. It is the basic chemistry. Okay.
Yes,
Here
ma'am.
you,
In terms of इलेक्ट्रॉन लूज, मतलब अगर इलेक्ट्रॉन गेन कर रहा है, इलेक्ट्रॉन लूज कर रहा है, तो उसको रिडॉक्स पोटेंशियल.
हाँ, तो if electron is accepting, then it is reducing. Here what is happening? These all the elements are accepting the electron. Okay, so they are electron. You are seeing, na? These are +4 to +2. These are forming the chain. So one electron is 2 electron is accepting manganese. Okay, so it is getting reduced. +4 to it is getting in the oxidation state of 2. So here it is reduction is going on. And you see here less amount of the oxygen is there. That is why reduction is going. अगर वहां पर ऑक्सीजन होता है, enough oxygen, तो वहां पर ऑक्सीडेशन होता है, रिडक्शन क्यों होता है ना?
Yes, ma'am. Thank you, ma'am.
So higher the positive value, the higher will be the reduction. Okay, and the lower the reduction potential, then it will tends to oxidize. Okay. Okay, one question I'm asking, you will tell me later or you clear it. You will see the submergent soil pH. What is the pH of the submerged soil?
Ma'am, neutral.
Yes,
Yeah,
ma'am,
everyone knows it, neutral. But why? Can you tell me why? If our soil is acidic, okay, then it also tends to move towards the neutral. And if our soil is alkaline and we pour lots of water, waterlogged condition we gave that soil, then it also tends to pH neutral. Why? हमारा अगर एसिडिक सॉइल है तो भी pH 7 की तरफ जाता है, एल्कलाइन सॉइल है तो भी वो pH 7 की तरफ जाता है वाटरलॉग्ड कंडीशन में. Why? What is this happening? We are science student, na? Agriculture is about the science. Even the soil science itself is a science, and in science we need to clear the concepts, the facts, okay? And the reason
Buffering capacity, ma'am.
what?
Buffering capacity.
But buffering capacity, how it is acting, na? Buffering capacity is what? Buffering capacity is to resistant to change. It resists to change. Okay. But here it is changing. From the alkaline, it is coming towards the neutral, and from the acidic, it is coming towards the neutral. So there is change. And buffering capacity is resistant to change. That is why I call it the buffer. Okay, if we would have much time in after the class, then we will discuss it. So remind me, or okay. So now our next topic is the management of soil aeration. So for the management of soil aeration, we need what are the factors? Improving the soil structure, we can improve. As we read, na, platy structure and the massive structure have the low soil aeration. So we can improve the soil structure by the using of the much more organic matter and manures. So it will improve our soil structure and it forms the soil aggregates. So there will be the soil aeration, optimum soil aeration. And then next one is drainage. So if water logging is there, then for the soil aeration, we need to drain out so that moisture will be low, so that our soil air can move or diffuse. And then the next point is light cultivation. Light cultivation is given for the fallow land, or the, what happens in the fallow land, there will be the low, in fallow land there will be no microbial activity or nothing will be there. So at the time passes, there will be the compaction. Okay, not the compaction, the consolidation or the slowly process happens, compression. Okay, but in light cultivation, there will be the activity, root growth or the activity of microbes. There will be the life. So the cultivation, if occurs, then there will be the good soil aeration. It will loses the soil. Okay, friable. It makes the soil friable. So there will be the good soil aeration. Then the plant adaptation. Plant adaptation means that species to species it varies. For the rice, we do not need much soil aeration. Okay, but for the other plants, we need. So we can choose the plant according to that for the soil aeration. Okay, for the deep soil, we can take the higher plants. Okay, so that the up to that depth soil aeration will be good. If we take the shallow rooted plants, then up to 15 centimeter it will be provide a good aeration. Okay. So these are all about the soil aeration. So, okay, I'm discussing that question, that in submergent soils, why it tends to having the pH neutral. You see, there are the two processes happens. Okay, what happens in alkaline soil? Alkaline soil having the, in alkaline soil, there is the higher root activity, sorry, not the root activity, actually the microbial activity. And what happens that there is the organic matter and it decomposes organic matter in alkaline soil. So as the decomposition of organic matter, see, in submergent soil, doesn't happen that the decomposition of organic matter doesn't happen. It is not so. Decomposition happens, I taught you na the aerobic decomposition and anaerobic decomposition. So decompositions occur. So as the decompositions occur, so weak acids are produced as the carbonic acid. So as the decomposition will occur or the microbial activity will be higher, so in alkaline soil, the CO2 concentration will increase due to the microbial activity, and CO2 concentration increases and it produces acid. It forms the carbonic acid. And even the organic matter also, when decomposes, it produces weak acids. So it lowers the pH and it tends to have neutral pH. And in acid soils, what happens? In acid soil, you see here. Okay, here it is not written, but you will see in DK Das or in any other book, this redox potential table, reduction process. You will see here some hydrogen ions are used for the reduction. Reduction process is what? Having the electron or losing the oxygen or having the hydrogen. These all are the reduction process. So in all this process, you will see like here you see CO2. Okay, CO2 is getting transferred into the CH4. What is happening? Here carbon is accepting hydrogen. So from the soil, H+ ions are getting trapped by the carbon dioxide and it is forming methane. So in acidic soil, what is there? There is the excess amount of H+ ions. So those H+ ions are getting oxidized and they reduce the others, like the carbon dioxide is reducing to methane. So here the H+ ions are getting consumed. So if if your H+ ions are getting consumed, then obviously there will be the increase in pH. So in acid soils, pH increases and it reaches up to the neutral. Okay, got my point?
Yes, ma'am.
These are the very important things. These are the very important concepts. For the JRF examination, we just rattamar at least, because we don't have that much time to clear the concepts. Okay, but for the MSc and the PhD students, we need to clear all the concepts, because in coming examination of the SRF or JRF, essence and result type questions are asked, or even after that we are facing lots of the interview. So in the interview, these questions are asked. They do not ask you the values only, they ask you the concept. Even if they don't know your interviewer do not know the answer, and if you give that kind of the answer, then they will be happy by you. Okay. So our next topic is soil compaction. Yeah, there is the two terms, compaction and consolidation. Both are the very confusing. Okay, so we will discuss it one by one. So soil compaction is the compression of the soil by the expulsion of air from the voids of the soil. Here the most important line is the expulsion of air from the voids of the soil. Okay, here it is expulsion of air. In voids, what is there? There are the air and water. So in compaction, we expulse the air from the voids of the soil, not water. Okay, then it is compaction. Or it is a very sudden process. What happens that if you has the loosened soil, okay, loosened soil and the friable soil. If you in agriculture, what happens? We use the tractor or the vehicles. So if we मतलब अगर ट्रैक्टर हम चढ़ा दे रहे हैं अपने soil पे, so what happens? It will compact our soil. So what happening there? It is compacting, and it is the between the soils there was the air present. So those airs are getting expelled. So those soils are getting compact. So expulsion of air, and it is a very sudden process due to the tractor or any vehicle it happens, and that soil is getting compact. So compaction, so what happens? It increases the voids is decreasing, matlab air filled voids is decreasing. So what is happening finally? So per unit volume, our soil mass is increasing. So the dry bulk density, the bulk density increases. Okay. And the factors affecting compaction are, here you can see in this image. Here the soil has the three forms, air, water, and solid. So for the as the sudden tractor will be there, and for the instant time, for the very low time, so then the air will be come out and water and solid will be there left. So that is the compaction. And some factors are there, like the soil stability and the soil strength. If our soil stability is higher, soil stability and soil stability is talking about the aggregation stability, aggregate stability, and soil strength is about the resistant to change, resistant to change to deformation, like the wet soil and dry soil. Okay, so dry soil have the higher resistance, okay, than the wet soil. In wet soil, if we can touch those soil and we just squeeze that, then it deform. But in dry soil we cannot squeeze out. Okay, so soil strength and the soil stability, and that is called as the compaction susceptibility. Okay, like the sand or clay. So compaction susceptibility will be higher in clay than the sand. So, and the soil textures, those are all the factors affecting the compaction. And the next point is soil moisture and soil water suction. See, the soil moisture is increasing, then it is dynamic with the soil air. So if increase in soil moisture, so it will decrease the air in soil. So if the increase in soil moisture will decrease the air. So if our air will be low, then the compaction will be low. If the air is high, then the compaction will be higher. Okay, and soil water suction, if soil moisture will be low, then the water suction will be high. Okay, so it also, and finally the compaction affects the conductivity, hydraulic conductivity and the permeability. Okay, here you will see these are the soil functions. Okay, those are directly affected by the soil compaction. For the air regime, you will see there are the air storage, air flow, which is affected, like the air capacity, dry bulk density, air permeability, oxygen diffusivity, all will affect by the compaction. Okay, higher the compaction, then the bulk density will be high, air capacity will be low, air permeability will be low, oxygen diffusivity will be low. Okay, and in the water regime also, if the bulk density will be low, available water capacity, if the bulk density will be low, then the water regime will be higher. And the water flow, like the water conductivity. Okay, if the higher the compaction, there will be the low the conductivity in the as for the saturated condition or the unsaturated condition. And even for the plant growth, plant production, you will see higher the compaction layer, it will be for the roots, it will be very tough to penetrate those tough layer of the soils to go through the under the soil and to find the water. Okay, so root length will be decreased, root length will be low as the compaction increases, and the penetration resistance will be high. Okay, and even it is not mentioned here, for the even germination will be low. You know, if the soil surface have the tough layer, then how will be the germination? So this compaction is a very affecting factor for our agriculture. And in our agriculture, we use the tractor and the most of the vehicles. That's why we are studying the soil compaction. Okay. So these are the some management practices to frame the compaction law. So first one is the reduction of the soil stresses, like the use of the enlarged, tired, overrun, bunker, like the means the use of the you know, these are the engineering parts, but we can relate it. So use of the low width tires. Okay, that will produce the less soil stresses. Okay, and the improvement of the soil's bearing capacity. Okay, bearing capacity means the resistance, means and that can be increased by the conservation tillages, reduced tillages, or the no tillages. Okay, and the further development of the technical solutions, like those are the engineering part. Okay, and adaptation of the cropping methods, like the adaptation of the row width to enlarge tire size, kind of. Okay, these are the some points. The main important point is to know the concept of the soil compaction. From there the question is asked. Okay, like the air means air factor is important, and bulk density increases, that kind of the questions are asked. Even at last I will discuss now some questions. You will see there these all the points. Next point is soil consolidation. See, consolidation is the process in which the volume of the soil decreases due to expulsion of water. See, there in soil compaction, there was the expulsion of air, but in soil consolidation, there is the expulsion of water from the pores. Okay, and that was the rapid process. But in consolidation, it is the slow process. Soil gets consolidated when effective vertical pressure increases. Means at first what happens if you are giving pressure to the soil, so at first the soil air comes out, okay, then again you are continuously giving the pressure, then water also slowly and slowly it will diffuse out, okay, that is called as the consolidation. So compaction was the rapid process, but the consolidation is the slow process. Okay, it is the function of the effective pressure. If water comes out from the pores, then air cannot take place. So at first compaction occurs in soil generally, then the consolidations occur. In the right hand side, you see this image. You know, there is the lots of the water, but after the consolidation, there is a low amount of water. Okay, so this is the consolidation, and consolidation is naturally happens in soil. Okay, but compaction is what artificially we are using the tractor or any vehicles, so that is the man-made or the artificial process, but consolidation is natural process. Means over the time it happens like for the soil, if you have any structure on the soil, so what happens slowly and slowly after some times there is the expulsion of water after many years. For example, our house is here now, our house is built, so underneath the house what is happening, so it is giving pressure to the soil, so over the time what is happening, the groundwater, whatever the water is present in the soil, it is expulsing somehow as the pressure is increasing day by day. So it is very slow process, so it is natural. Okay, here it is a brief. I have given you some points, difference between the compaction and consolidation in summary. So compaction is a quick process and consolidation is a slow process, as we have discussed. Okay, and compaction is the compression of soil by the expulsion of air, whereas the consolidation is the expulsion of water. It is the process where the mechanical pressure is used. I told you, it is an artificially we give it to the soil. So it compresses the soil mass for the purpose of the soil improvement or whatever. It is unintentional process, but in consolidation, it is a process where steady and static pressure slowly, for example, our house causes compression of the saturated soil. Fourth one is dynamic loads by rapid mechanical methods like the vibration, damping, and the rolling are applied for a small interval. For the small interval, see, it is very instant process, but consolidation is what? It is the static and sustained, means for a long period of time, long interval. The fifth point is the compaction process can be completed immediately. Okay, while the consolidation is a slow and steady process, it takes time. Sixth point is compaction is an instantaneous process of reduction of volume of voids. Okay, question is asked from these points. Volume of voids is decreasing, whereas consolidation is a time dependent process of reduction of volume. Here the total volume is decreasing in consolidation. And seventh point is compaction is an artificial process, consolidation is a natural process. Compaction loading period is short, that is the same thing. Okay, and compaction is the primary process and consolidation starts after compaction. I told you at first the airs will come out, then only the water will move out. So compaction is the primary process and consolidation starts after the compaction. So these are the topics for today's. I think we have lots of time left. So up to here, anyone have any doubt? So then I will discuss some questions. I have questions for you.
Excuse me, ma'am.
Yes.
Ma'am, if we compact the soil, then water will also expelled out, not only the air.
No, see, it is unintentional process. We are not doing it, I mean, intentionally, compacting. At first, it is instantaneously. So matlab instantly, only the airs will come out for the very short period of time. We are not running our tractor in the waterlogged soil. Okay.
Okay, ma'am.
In general soil, in normally soil, we are doing that. So in normally soil, what you see, if there is, I mean, in naturally when we see the soil, can you see the water in soil? No, we can't see that much amount of the water in soil. Okay, so how can you say that the instantly water will come? It happens that in soil, when we apply the water, okay, irrigation is there, okay, and then we move our tractor. So have you seen where the tractor has crossed, there is the dry portion?
No, ma'am.
No, we don't see that. If it will happen, then there will be dryness.
Okay, ma'am. Got it.
Ma'am,
Yes.
ma'am, there is a term related to this I've read in DK Das, that is compression. In compression also the total volume decreases or the pore space decreases? But the pores
Actually,
volume decreases.
compression is both the thing. Actually, you can say the compaction and the consolidation. We can say that the compression is compaction and consolidation, but not vice versa. Compression means what? We are compressing the things. Okay. So that is in general cases. We are compressing the soil, the voids will, the airs will be low and the water will be low. But the main difference is between the compaction and consolidation. That's why I'm discussing it.
Okay, thank you.
In both cases, compaction and consolidation, we are compressing the soil. Okay, any doubts? Otherwise, I will ask questions. Okay. So my first question is air capacity of soil should be greater than what for all the crops except paddy? What percentage of air capacity should have the soil for the growth of the crops rather than the paddy? 10%, 20%, 30%, 40%.
30%, madam.
Any other one?
Ma'am, 20%.
10%, ma'am.
Yes, it is 10%. In previous slide, I have shown you this graph. Wait. Here, you see, I told you now, after the 10% of the airfield porosity, there is the good growth we see usually in our plants. Okay. So air capacity, what it should be? 10%. These are the points to remember. Okay. The soil strength of soil is positively related to its bulk density, moisture content, both or none.
Bulk density, ma'am.
Okay. Anyone have other answer?
Both, madam.
Okay. Anyone have other than 4 options? Answer for other than 4 options? See, answer is bulk density. Read the questions properly. Okay. Even questions have the answer. So read the questions. The soil strength of soil is positively related to it. It is asking about the positively related. Okay. Bulk density or moisture content. So it is positively related to the bulk density. So bulk density will be higher, the soil strength will be higher. Soil strength is what? It is the resistant to deformation. Okay. If the moisture content will be higher, I told you now, if the like the clay soil, gila soil jo hota hai, like the wetty soil, we can squeeze out, we can deform the soil, na? But the dry soil we cannot. So soil strength is what? Higher in what? Dry soil than the wet soil. So it is not positively related to the moisture content. Okay. In the next question, you see the soil strength is inversely related to its
Moisture content.
Moisture content.
yes. Here it will be the moisture content. Now you have all got the point. Okay. Next question, you see, which gas has more percent volume composition in swampy rice land?
Carbon
Nitrogen.
dioxide.
Nitrogen.
Ma'am, carbon dioxide.
Carbon dioxide, ma'am.
Okay, and anyone said nitrogen?
Yes, ma'am. Because
Okay.
it forms methane. That's why I said
Because it forms.
methane.
So nitrogen is not methane. How you related methane? How you related methane to nitrogen? What? I'm not getting your voice.
कशाले
Subham Rathod. Either mute yourself or give me answer. See, the answer was right. It should be nitrogen actually, not the carbon dioxide. You see, the question is what? Which gas has more percent volume? It means ki which gas will be higher in swampy rice land. You see, in the swampy rice land means there is the low amount of oxygen. So obviously oxygen will not be there. So this option is eliminated. Okay. So out of these three, you will see swampy rice land, it produces methane. So carbon dioxide is directly get converted into methane. So carbon dioxide is not higher amount, na? Is not in higher amount. Okay, so you, Ritik, you eliminated the option. I said that was you told that the methane production will be high, right?
Yes, sir.
Okay, I got your point. So nitrogen will be high amount. In the waterlogged soil, I told you, denitrification is higher. So nitrogen gas production is higher. Okay, got your point, or I need to explain more and more about this? Okay. Our next question is compaction of a soil due to golf cart traffic would cause the bulk density. Increase, decrease, not change, be unity.
Increase.
Increase.
Yes, concept is cleared. Compaction of soil causes the water holding capacity. Increase, decrease, not change, be unity.
Decrease. Decrease.
Yes, very good. Soils with higher water stable aggregate will have a high proportion of small pores, large pores, very small pores, none.
Ma'am, very small pores.
Small pores.
Who said very small pores?
Ma'am, me.
Okay. There are lots of participants, but they are not giving answer. Only some people are very active. It is like it is the online class, but as in the offline class, what happens? The front rows, students are very active, and others are like front bench students are there to give the answer. Why we need to take any tension, right? So soils with the higher water stable aggregate will have the high proportion of, answer is large pores. See here in question it is about the aggregates. Okay, higher the aggregate stability, the higher will be the macropores, right? Not the small pores and the very small pores. Small pores and the very small pores are in the silt and the clay soil. Okay. So as if the aggregation happens, then the soil particles will size will have the more and more. So there will be the macropores. You get the concept of the aggregation actually at first, you guys. Then you will understand the pore size or these are the very easy words and topics, but these are the very basic things. If you do not get clear about the aggregates, you will not solve any conceptual questions. Why this soil aggregation forms? Have you read the flocculation and dispersion?
Yes, ma'am.
So what causes flocculation and what causes dispersion?
Ma'am, this humus, divalent ions, and clay particles causes flocculation.
Yes, you are right. And dispersion?
Ma'am, basically sodium ions causes dispersion of particles.
Okay. So we all know that dispersion is caused by the sodium and the monovalent. Okay. But the aggregation is caused by the divalent, like the calcium or magnesium ions. But actually, what happens there? Tell me. How calcium?
Excuse me, ma'am.
Yes.
Ma'am, excuse me. My network was weak. Please explain once again. What you said?
Actually, I'm not explaining. I have a question that soil aggregation or the flocculation is due to the calcium. You all know, na, calcium or the organic matter. Okay?
Yes, ma'am.
Whereas the dispersion is due to the sodium. Why?
Yes, ma'am.
Why? These are all the facts. You just remember the things. You matlab ratta maar lete hain type. But what is the concept? Why? What happens there? What does sodium in soil? Anyone can give me answer.
Sodium basically increases the zeta potential, due to which dispersion occurs. The particles repel each other basically.
Okay. And
whereas
calcium?
in case of calcium and magnesium, it decreases the zeta potential and it causes the particles to come closer.
Okay. And what is zeta potential? You know clearly? I mean, you have a clear concept now, or you have just ratta mara. I mean, just remember the things. Your answer is right. Your answer is right.
Ma'am, potential between two layers in the clay particle. If one is soil particle and other is with contact with the solution.
Yes, ma'am, between the diffuse layer.
Yes, ma'am.
Okay, that is the same thing, but in the other terms, just to understand, I'm explaining that calcium having the higher charge. Okay, so it will comes to the soil colloids immediately. Okay, and it is the ionic potential charge upon the size ratio. You will see sodium has the higher. What happens in soil? Everything is hydrated. Okay, sodium is there and calcium, any ion is there. So we do not directly study about there is a sodium ion, there is the calcium ion, but we have to understand that is in the hydrated form. There is the soil moisture present. So sodium is surrounded with the water. Calcium is also surrounded with the water. So what happens? You have read somewhere that the lower this size, like the sodium has the lower size than the calcium, but hydrated size of the sodium is higher than the calcium. Okay, so higher the sodium is surrounded by more and more number of the water than the calcium is surrounded by water. Okay, so due to the higher hydration cell in sodium, it has the charge, low charge, and it +1 charge so it has we have, see here it is the colloids and here it is the negative charge. Okay, there is the sodium having the small size, but it is surrounded by the large number of waters, so it is in bulgy nature. And here is the calcium surrounded by less amount of the water and having the higher charge. So see which one will get attracted towards the colloid first? Obviously calcium.
Calcium. Yes,
Having the higher charge and the low amount of water surrounding it, it will produce low hindrance, okay, towards the colloid. So that is that will be what is happening. Calcium ion is getting attached to the colloids and it forms the breezes through the organic matter or through the any other soils, like the calcium to the calcium, clay, calcium and organic matter, clay, calcium, or you will read these all things in organic colloids or in this clay humus complex, like that. Okay, so these are the breezing elements. So it attracts more and more number of the soil particles in soil, so it forms the aggregation. Okay, that is why calcium and the magnesium is for the flow, it causes the flocculation, while the sodium causes dispersion. Okay, so wait, we have much time. My another question is, it is very interesting question. Calcareous soil have the pH 7.2 to 8.5, 9.5, 7 to 14, 8 to 12. Which one? You all have no the laterite soil, red soil, calcareous soil. Yes, na? Am I audible?
One number now.
Other
Ma'am,
people?
8.12.
What? 8 to 12.
Ma'am, the
Yes.
first number 7.2 to 8.5.
Yes, that's
Ma'am,
correct. Yes, it is up to 8.5 pH. Okay. So this is also factual that you all know that the fact that the calcareous soil have the soil pH 8.5. But now you tell me why it has the pH only 8.5? Why it doesn't increases greater than 8.5? Think. Science is about to think. As much as you will think, that much you will have the clear the concepts.
Ma'am, because it has carbonate also, which combines with the H positive ions of released by the water, and it forms carbonic acid. Like due to this, the pH cannot exceed the values of 8.5, I think.
See, the reason is correct, but actually not well correlated, I will say. See what happens. At first, calcium carbonate is calcareous soil has the excess amount of the calcium carbonate. Okay, so calcium carbonate is the strong acid, strong base. Okay, so it will break down into calcium ion and the carbonate ion. So calcium carbonate with the water, so calcium ion will form the calcium hydroxide, okay, which is a strong base. So hydroxide will increase the pH, okay, and bicarbonate will be formed. So, but what happens in soil? I told you na, ki CO2 concentration is much higher than the atmosphere in our soil. So if the CO2 and bicarbonate will again, it will be break down and it will form the CO2 and water. Na, carbonic, it will form carbonic acid H2CO3, and H2CO3 again it easily break down into the carbon dioxide and the water. Okay, so after a time, that is after the pH of the 8.5, what happens in soil? Carbon dioxide concentration is high. So you know, due to you have read Lee-Chatelier principles, that if the our product side, that the bicarbonate ion or the CO2 concentration is high, okay, then it will form the bicarbonate. So bicarbonate ions will be higher in concentration. So then what happens if product side, if the concentration is high, then our reaction goes towards back. We know na? So due to which our reaction goes towards the back after the 8.5 pH. So it doesn't mean that calcium carbonate is not breaking down and calcium hydroxide is not forming. It is forming, but our back reaction is rate of back reaction is higher than the forward reactions. That is why after the 8.5 calcareous soil reaches up to pH of the 8.5. Get my point? Clear
Not
or not?
completely, ma'am.
What?
Not completely, ma'am. Not completely, ma'am.
Okay, Lee-Chatelier principles, you know, na? If you have reversible reaction, okay, in reversible reaction, what happen? If the
Product can change into
product can change
initial
into
product.
the back reaction can be there, but when the product when the concentration of product will be higher than the reactant, okay, then the backward reaction will increase. So calcium carbonate is breaking, and the carbon dioxide is forming. But after the 8.5 pH, carbon dioxide concentration is higher in soil, much. Okay, then the so what happens? Carbon dioxide concentration is high. So then it again get reacted to the hydrogen and it forms bicarbonate, and it again there is the excess amount of calcium. Okay, so these bicarbonates again react with the calcium and it forms calcium carbonate. See, so H plus ion is getting consumed here. Get my point?
It means, ma'am, then equilibrium condition will reach.
No, it is not about the equilibrium condition. At the 8.5 pH, it will be equilibrium condition.
Yes, ma'am.
But this is, my question was, why doesn't exceed 8.5 pH? So this is because there is the formation of the bicarbonate, okay, or the carbonic acid. Because the CO2 concentration is higher after that in soil. These are the soil chemistry. So next question is method to determine the CEC. CEC is what? Cation exchange capacity. With what method we determine the cation exchange capacity?
First, ammonium acetate.
Yes, ammonium acetate. There are two type of the CEC. Now we read effective CEC and the CEC. Three type of the cation exchange capacity, anion exchange capacity, and the effective cation exchange capacity. Have you are you familiar with the term effective cation exchange capacity? Anywhere?
Yes, ma'am. I did once. I have read once.
What happens in effective cation exchange capacity?
And total cation exchange capacity exceed with anion exchange capacity.
What?
Ma'am, I don't know the exact reason.
So,
only I have read once.
I told you this misconcept will give you negative points. जो भी मार्क्स आना होगा वो भी कम हो जाएगा. So be clear. Anyone effective cation exchange capacity? Tamanna or lots of people were answering me. Okay, cation exchange capacity, we determine all the cations except the aluminium, all the basic cations actually in the cation exchange capacity. But in the effective cation exchange capacity, we also consider the aluminium in soil. Okay, that is an acidic cation that forms the acid. In soil acidity, you have read that free aluminium ions and the iron ions are responsible for the acidity. Okay, it reacts with the water and it forms aluminium hydroxide, and in soil solution it releases hydrogen ion. Okay, So it is responsible for the acidity. So in effective cation exchange capacity, we consider also the aluminum. So for the CEC, we use the ammonium acetate, okay, because ammonium is also a cation, okay. So what we do that in soil colloids, we provide these soil colloids with the excess amount of the ammonium acetate. So what happens, that ammonium gets attached to the or exchange with the all those cations, okay, like the calcium, magnesium and all. But aluminum has what? +3 power. You know, flocculation power you have read now in lyotropic series. Aluminum is greater. Aluminum has the highest, then the calcium, magnesium, and then the nitrate and chloride. Okay. So aluminum has the very high flocculation power. So ammonium is the +1 charge. It doesn't have power to replace the aluminum from the soil colloids. Okay. So with which we cannot determine the cation exchange capacity. So in effective cation exchange capacity, we use KCl, ammonium acetate plus KCl. These are questions asked. The reason for the effective cation exchange capacity, like, so ammonium acetate plus KCl. Okay, so ammonium is a cation and potassium is another cation. So both meet together and they both replace the aluminum from the soil colloids, and then the aluminum comes into the soil solution, and from the soil solution we get the estimation from the flame photometer or whatever. Okay, so these are the some methods through which we determine the cation exchange capacity. Here in next question you will see ammonium acetate method is not suitable for estimation of CEC of which soil? Laterite soil, red soil, calcareous soil, or the black soil?
Ma'am, calcareous soil.
Yes. Why? Told you now, there is always a reason. Okay, read it later because we are running off time. Okay, actually it produces soluble. So actually what it does, in calcareous soil there is the excess amount of the calcium. Okay, so it doesn't give the accurate calcium estimation, ammonium acetate. So we do not use ammonium acetate there. In TD Biswas and Mukherjee, I think this reason was very well explained. At least read that book, you know, TD Biswas and Mukherjee is like the NCERT. Every line is important. See, for this soil science, we study the ISSS fundamental introduction, that much of the, you know, quantity. But TD Biswas is what? That much of. All this soil science is written there. So direct information type. But some things are, some topics are very well explained. So these topics are also explained there. So go and read their soil chemistry. Okay. So our next question. Okay, first question we have already discussed. Okay, and okay, tell me third metric potential will be 0 when? In okay, I'm giving you option. In saturated soil, in unsaturated soil.
Saturated soil.
Yes. Why?
Means because ma'am, water have no tendency to attract any of more cations. Ma'am, free water has one power. I mean, one. It is said to be that. Then saturated soil should be 0.
What is see? What is the metric potential? So metric potential is first about the soil matrix, and we are talking about the clay. Okay, clay particles. So or any soil particles. So metric potential is the form of the water film or anything like the which are bound with the any soil particles. That is the metric potential. Okay, so that are not easily available. So when there will be the saturated condition, there will be the lots of the water, enough water, then obviously metric potential will be 0. Means we do not need to pull out waters from the film of the colloids. Okay, and difference between the BOD and COD. See, full form of even BOD and COD is biological oxygen demand or the biochemical oxygen demand, like this. Okay, this question we will discuss in second half. Okay, difference between the BOD and COD. So you guys read it, and in the second half we will discuss it. Okay, there are some more questions from the soil colloids.
Octahedral.
Octahedral, ma'am.
Yes, right. Why? How can you say that in the octahedral? I'm asking too much. Why? Huh? Actually, you know, you see that the montmorillonite is what type of the clay, expanding or non-expanding?
Ma'am, expanding.
Expanding.
Yes. So what happens? 2:1 type, na? So 2:1 type means what? Tetrahedral, then octahedral, then again tetrahedral. So this one is the one layer. Okay. Then there is the interlayer space, and there is the another tetrahedral, octahedral, and tetrahedral. So what happens? Octahedral is sandwiched between the two tetrahedral layers. Okay. So if there will be the isomorphous substitution in the octahedral layers, okay, then what happens? There will be the negative charge on the whole layer. Right? It will be uniformly distributed. We just assume that the negative charge due to the isomorphous substitution is uniformly located on the clay. Okay, on the first layer there is the negative charge, and the another layer there is also negative charge due to isomorphous substitution. So what happens? Due to negative charge, okay, so interlayer space is there. These due to both have the negative charge, so they repel each other. So when in the presence of the ethanol or ethanol glycerol, what happens? They repel each other and they expand more and more. So these are the points. In 2019 JRF examination, this question was asked for the maybe for the montmorillonite or the smectite. It was asked. See, in which layer of the mica isomorphous substitution occurs?
Ma'am, tetrahedral.
Now you can explain me how, right now? I have explained already montmorillonite. If there is the isomorphous substitution in the octahedral, then they can expand. But mica is expanding or non-expanding?
Non-expanding.
Non-expanding.
So the isomorphous substitution would be where? In both? Or tetrahedral or octahedral?
In tetrahedral.
Okay, tell me, in interlayer spaces of the mica, which ions are present?
Potassium.
And potassium.
And it is loosely bonded or tightly bonded?
Tightly bounded.
So now relate it. Tightly bonded to whom? To which layer? To which seed?
Tetrahedral.
Obviously, it is bonded with the tetrahedral layer. Okay, tetrahedral seed. So it means that the tetrahedral seeds have some charges, na? Is it? So obviously, in mica, isomorphous substitutions occurs in the tetrahedral layer. In tetrahedral layer, what happens? There is the development of charge. Okay, and that is the negative charge. So to balance those negative charge, it takes the potassium ions, okay, from the soil solution, and it is tightly bonded, because here from the one layer there is a tetrahedral sheet, from the another layer there is a tetrahedral sheet, and between the interlayer, between those both tetrahedral sheets, the potassium is tightly bonded, so it is not freely available. Okay, so in mica, isomorphous substitution occurs in tetrahedral. These are the very important points, and even to me, I have taken 2 years to complete these concepts, because I could not visualize these things. Which layer is there? I read every books, but to visualize the things, if you visualize the anything, if you have the power of imagination, then you can easily understand the things. Is it?
मैम मोंट मोलनाइट का एक बार फिर से एक्सप्लेन कर दीजिए तो।
अच्छा देखो, मॉन्ट मोलनाइट में क्या होता है कि मॉन्ट मोलनाइट इज एक्सपांडिंग, ठीक है। एक्सपांड कब करेगा? जब वो एक दूसरे को रिपेल करेगा ना। इंटरलेयर स्पेस जो होता है, बेसल स्पेसिंग होता है ना, बेसल स्पेसिंग फ्रॉम द फर्स्ट लेयर टू अनदर फर्स्ट लेयर, दैट इज कॉल्ड द बेसल स्पेसिंग। बेसल स्पेसिंग इंक्रीज करता है। उस बेसल स्पेसिंग इंक्रीज करने में क्या क्या होता है? इंटरलेयर स्पेस भी आता है। यानी ऑब्वियसली जो सीट है, जो सीट है वो तो नहीं ना इंक्रीज करेगा। सीट विल नेवर इंक्रीज दिस साइज, okay, that is bonded to each other, tetrahedral sheet to octahedral sheet, and then the tetrahedral sheet. These will not expand. Expansion is where the interlayer spaces, when you provide the ethanol or any glycerol. Okay, so what happens? It tends to 10 to 14 angstrom or 17 angstrom actually in for the montmorillonite basal spacing, just due to the having the same charges. See what happened, अगर जो isomorphous substitution है montmorillonite में, अगर वो टेट्राहेड्रल में होता तो बोथ टेट्राहेड्रल, एक लेयर का टेट्राहेड्रल और दूसरे लेयर का टेट्राहेड्रल, मतलब कि एक लेयर का लोअर वाला टेट्राहेड्रल सीट और दूसरे लेयर का अपर वाला टेट्राहेड्रल सीट, और इसके बीच में क्या है? इंटरलेयर स्पेसिंग, ठीक है। तो अगर टेट्राहेड्रल सीट में अगर होता है सब्स्टिट्यूशन, तो एक लेयर का जो लोअर वाला है टेट्राहेड्रल सीट, इस पे नेगेटिव चार्ज डेवलप हुआ, ठीक है, और दूसरा लेयर का जो ऊपर वाला जो है टेट्राहेड्रल सीट, इसमें नेगेटिव चार्ज डेवलप है, ठीक है। तो ये क्या करेगा? दोनों पास में है ना, दोनों पास में है, और वहां पे इंटरलेयर स्पेस है। तो यहाँ पे क्या होता है कि कोई भी बाहर से कैटायन, जो कैटायन एक्सचेंज कैपेसिटी भी हम लोग जो पढ़ते हैं, जो इंटरलेयर में जो कैटायंस हो जाके वो होता है, अटैच्ड हो जाता है, वो भी यहीं पे आके, तो वो क्या होता है? ड्यू टू दिस चार्ज टाइटली बॉन्ड हो जाता है। केओलिनाइट में क्या होता है? वन टेट्राहेड्रल, वन ऑक्टाहेड्रल, देन अगेन वन टेट्राहेड्रल, वन ऑक्टाहेड्रल। सो एक लेयर का क्या हुआ? ऑक्टाहेड्रल सीट, और दूसरे लेयर का क्या हुआ? टेट्राहेड्रल सीट। इन दोनों के बीच में देखो, ऑक्टाहेड्रल में क्या है? OH है ना, एल्यूमिनियम हाइड्रोक्साइड है ना, और इधर टेट्राहेड्रल में क्या है? टेट्राहेड्रल का स्ट्रक्चर देखना, सिलिकॉन होता है और ऊपर में एपिकल ऑक्सीजन होता है ना। टेट्राहेड्रल फॉर्म में 3 ऑक्सीजन एक प्लेन में होता है और एक ऑक्सीजन ऊपर वाले प्लेन में होता है। तो जो ऊपर वाला ऑक्सीजन होता है सिलिकॉन टेट्राहेड्रल का, ये ऑक्सीजन जो है उसका OH के साथ, समझ ना, हाइड्रोजन है वहां पे, तो दे विल फॉर्म द हाइड्रोजन बॉन्ड डायरेक्टली, तुरंत उसको मिला वो तुरंत बॉन्डिंग कर लेगा। और हाइड्रोजन बॉन्ड वी नो दैट इज वेरी स्ट्रांग इन नेचर, that is why the keolinite are not the expanding in nature. Got my point?
Yes ma'am.
Okay, Suman, are you there or not?
Yes ma'am, I am here. Hello. Yes ma'am, I am here.
Okay, so
Hello.
I think that much we have discussed, and I think that will be useful for you guys. You can give me my feedback.
I am here ma'am. Am I audible ma'am?
Yes, Suman, you are.
Hello.
Yes, Suman.
Yes sir. Thank you ma'am. Thank you for giving this precious time to the students, and I hope they cleared the at least soil, air, and so many concepts related to soil science, and they cause some confusion to the students. You explain all these things in very simple manner. Thanks for that, ma'am.
Okay, in the second
We
half,
next class. यस मैम, मैं इनको बताना चाहता हूँ कि सेकेंड क्लास भी मैम का ही है और वो सॉइल टेम्परेचर पर है, आप सभी ज्वाइन करेंगे इन टाइम। मैं अभी आपको ये भेजता हूँ लिंक, लेकिन हमारा टाइम जो होगा वो 3:30 से होगा। इट्स ओके ना मैम? 3:30?
हाँ हाँ, ओके ओके।
ओके, 3:30।
Thank you, ma'am.
if you guys have any queries, you can ask me, okay, in second half also.